Greetings. My presentation today is on the relative incidence of tomato spotted wilt in Phorate-Treated and non-treated peanut. Albert Culbreath, and I'll be your presenter today. Tomato spotted wilt caused by tomato spotted wilt virus comes with a variety of symptoms and continues to be a challenge for peanut production in the southeastern U.S. The virus is vectored by thrips, and we believe the western flower thrips and to a greater extent tobacco thrips are the main culprits. Tobacco thrips do direct damage on young peanut, but incidence of spotted wilt typically hasn't correlated with thrips control or levels of thrips feeding injury. Although most insecticides we've evaluated for thrips control have little effect on spotted wilt, Phorate insecticide applied in-furrow has provided suppression of the disease as well as thrips control. Phorate is a significant part of the integrated program for management of spotted wilt. In the current risk index, use of no insecticide or insecticides other than Phorate carry a relative risk index value of 15, compared to 5 points, a significant reduction when Phorate is used. Much of the initial work from which the risk assessment values were calculated was on Georgia green. This cultivar responded strongly to application of Phorate as well as other management practices. However, now we have cultivars with much greater field resistance and tolerance than Georgia green. Therefore, the objective of this study was to examine the relationship of Phorate versus non-treated peanut on the incidence of spotted wilt and yield in the cultivars we have available now. In this study, we used results from 16 different field trials conducted at the University of Georgia Tifton campus Lang-Rigdon Farm from 2015 to 2019. The trials included 7 different cultivars with varying levels of field resistance and tolerance. Final ratings of spotted wilt incidence and pod yield were used for comparisons and for regression analysis. From all the trials, plots treated with 1.12 kilograms per hectare active ingredient of Phorate applied as Thimet 20G were compared with non-treated plots of the same cultivar from within the same replication. A total of 263 pairs of plots were utilized. A paired t-test was used to compare final incidence of spotted wilt and yield for the treated and non-treated plots. Regression analysis was conducted where we regressed final incidence of spotted wilt and yield from the plots treated with Phorate on the same values from respective non-treated plots. This picture shows plots of Georgia 12Y in which there was very little spotted wilt regardless of insecticide treatment. In striking contrast, plots of Flow Run 157, in which there was a very noticeable reduction in spotted wilt incidence in Phorate-treated plots compared to the non-treated. Across all trials, final incidence of spotted wilt ranged from 1.6% to 58.3% in the non-treated plots, and from 0 to 41.6% in plots treated with Phorate. Yields ranged from 3,660 kilograms per hectare to almost 9,500 kilograms per hectare in non-treated plots, and from about 3,900 kilograms per hectare to 9,400 kilograms per hectare in the treated plots. Across all trials, final incidence of spotted wilt averaged 17.9% in the non-treated plots and 11.5% in plots treated with Phorate. This was highly significant. Looking at the relationship between treated and non-treated plots, the dashed line shows the expected relationship if the two treatments are similar. The red line shows the observed relationship where incidence in the treated plots in most cases is well below the predicted dotted line. Incidence in Phorate-treated versus non-treated plots was described by the line with an intercept slightly but significantly above 0 with a rate of 0.49. This suggests that as disease pressure increases, the relative benefit of Phorate would also increase. There was also a significant effect on yield. Across all trials, yield was approximately 6,700 kilograms per hectare in the non-treated plots and approximately 7,000 kilograms per hectare in plots treated with phorate. Again, this was highly significant. When we look at the relationship between treated and non-treated plots, the dashed line shows the expected relationship if the two treatments are similar. The red line shows the observed relationship, where yield in most of the treated plots is above the predicted dotted line. Yield in phorate-treated versus non-treated plots was described by the line with an intercept well above zero at a rate of 0.62. This suggests that benefits of phorate are greater on the lower end, that is when the non-treated plots have the lowest yields, presumably in this trial related to higher disease levels. As yields in the non-treated plots increase, the relative benefit of phorate diminishes. In summary, there was a linear relationship between the incidence of spotted wilt in phorate-treated versus non-treated plots. Incidence of spotted wilt in phorate-treated plots increased according to a rate approximately 1/2 that of incidence in non-treated plots. There was a weaker and less pronounced linear relationship between yield in phorate-treated and non-treated plots. There was a strong yield advantage to phorate-treated plots when non-treated plot yield was low, but yields converged as yield in the non-treated plots increased. Results from this study indicate that phorate insecticide continues to provide suppression of spotted wilt epidemics, and that benefits from phorate for spotted wilt management increase as disease potential increases. Thank you. I appreciate your attention.